are beginning the Chapter 3 material here. This is section 3.1, and it has to do with just introducing functions. Right? And so the first thing to identify is whether something is or is not a function. For it to be a function, means that when you have an input will yield, or every individual input will yield one and only one distinct output. Okay, now, two inputs can yield the same output, but two of the same inputs cannot yield different outputs. And when I talk about inputs and outputs, I'm referring to, for what you guys are probably most familiar with, is inputs refer to x's, outputs refer to the y's. Right? So there's a couple different forms that you're going to be asked to identify whether something is or is not a function. Okay? And so one is a table of values. So here you have a table where you have a column of x's and a column of y's. Okay? So if you're looking to determine whether that representation shows a function, what you're looking for is, do you see any inputs that are the same? Okay, so when you look at that list here, are there any inputs that are this? Actually, let me remove this first. Okay, so are there any inputs that are the same in this set right here? No. When you look at all the inputs, they're all completely different, so you don't even need to worry about it. Each of these inputs here represent an output. There's no repeated values of x that give different values of y. So if you see it in this form, it would just be, yes, this is a function. Every input corresponds directly to one and only one output. Okay, now, that changes, however, if I make one adjustment. Okay, so let's say I add another set of points to 5. Okay, if I add this to my table, I now have a repeated x value. So here I have this value of x that's repeated 2 different times. Okay? In order for this to remain a function, the outputs would have to be the same. Are they the same? No, one time an input of 2 gives you a 3, the other time the input of 2 gives you a 5. And this is not a consistent with a function. Okay, a function means every input will always give a specific output, so this one would be no. If you add this set of points, you would get no for that. Okay. Right, when you look at the second table of inputs and outputs, okay, where you have arrows sort of representing what an input leads to. So an input of -5 leads to 3, 3 leads to 0, 2 leads to 3, 7 leads to -1, 0 leads to 0. Okay, so when you look at these values here, does each input lead to one and only one distinct output? No. What's the one that leads to 2 different ones? Again, 2 in this case. Again, this is just another way of representing this set of information, right? These are the same sets of inputs and outputs, just represented a little bit differently. Okay, so here we see that this input of 2 can either lead to 3 or a -5. Therefore, this is not an example of a function. Okay, now, you can also represent these same set of points here using ordered pair, okay, where the input is the x, the output is the y. So if you look at this as ordered pair here, okay, does this represent a function? Okay, are there any 2 values of x that yield different y values? Okay, so when you go through and you look, 4, 3, -3, 0, -2, -7, are any of those even repeat each other? No, so you don't even need to worry about it. This is going to be a function. Okay, what about this last example? Is that a function or not a function? You have 2 different inputs here and here that are the same. Do they yield the same output? No, and that's your answer the answer to that question is the answer to whether this is or is not a function. Okay, because those two inputs yield different outputs, this is not considered a function.